the important high-level information. And I am going to start with our project scope and background. Mapumba village in the Umlonga constituency or Angwena region in the outskirts of Namibia is one of the areas that still adapt to primitive ways of lighting, which is candle lighting and wood lighting. We have 52 houses of about 3,000 inhabitants in Omabumba village, and 90% of these inhabitants still use primitive ways of lighting, and it's about 46 houses. There has been cases of house burning resulting from the usage of candle and wood burning as a source of energy, because we use candles and the burning of wood as a source of energy. So this has resulted in burning houses. I remember growing up, because I grew up in the Mapumba village with my grandmother. December 2007, the 31st of December, our house caught fire, and this was a result of this, the use of candles. So all this bears the initiation behind this project, which aims at providing Omapumba village with reliable and renewable photovoltaic solar energy. The system is expected to provide about 2 megawatt power with over 30 years durability. We all know the world is moving towards sustainable development, and this project aims to better and conserve Omapumba village environment while also meeting the government of Namibia halfway towards sustainable development. So we have opted for photovoltaic solar energy source. We are going to move on to our scope and boundaries of this project. The purpose of this project is to provide an alternative source of lighting in Omapumba village, an off-grid photovoltaic solar energy. And this system will cater for at least one outdoor light and one light per room in every house. Renewable Solution CC, which is our company, will be the main project planner. Yes, I'm seeing some connectivity issues. Are you able to hear me? Can you hear me before I continue, please? Can everyone hear me? All right, other people can hear me. I think you are having some connectivity issues. Well, moving on to our scope and boundary of this project. The purpose of this project is to provide an alternative source of lighting in Omapumba village, an off-grid photovoltaic solar energy. This system is expected to cater for at least one outdoor light and one light per room in every house. Renewable Solution CC, and this is our company, will do the project planning, and we are presenting it here today. The project proposal document will be submitted to our stakeholders for approval. Our stakeholders is identified as the village headman of Omapumba village, Mr. Thomas Amfenu, and his community, the Ministry of Environment and Tourism, also one of our main stakeholders. This project is expected to make an annual income of about $1.5 million Namibian. Sorry. The project manager of this project is Maria Paula. We have identified the roles of our project manager to ensure communication between all involved parties in this project. she is going to ensure that communication is made between stakeholders. She's also going to monitor the progress of this project and validate that work packages are carried out within the scope and milestone. The boundaries of this project, we decided that it will only include 46 houses, and that is 90% of the inhabitants, and it does not include the local school as well as the cooker shops. Upon completion of this project, we will provide support and training, which will be provided to 4 members of the Omapomba village in order to facilitate the operation and maintenance of the system. The system, it will also be tested after completion to ensure that we have come up with a reliable system, and that will be done in a period of 2 months before we hand it over to our sponsor. Having presented that, I would like to take a look at the picture on the whiteboard on the screen. This is a picture of an area which was taken in Omapomba village. We see that open area, there used to be trees 10 years back. Now we can see it's appearing green like a desert. So the use of burning wood have resulted in this, and we want to conserve the environment of Omapomba. On the left-hand side, it appears the Google location of Omapomba. It is between Omthia and Nana in the Hangwena region. I would like to move on to our next slide, which is the I'd like to move on to our main deliverables. The main deliverables of this project are associated with 3 major phases of this project. Our major phases of this project is project initiation, project design, and project execution. So our main deliverables are project initiation. After the process of project initiation is done, we will be able to get our project initiation documents from all our stakeholders involved. And then after the phase of design, we will be able to get all our design papers, our electrical design papers, our civil design papers, our structural design papers, and our solar panel layout design papers. And then our last phase, which is the project execution, we are expected to get an efficient low voltage output system of 240 volts, let me say between 220 to 240 volts output, our system commissioning documents to make sure that the system was commissioned. And then we must be able to get our 4 skilled, our 4 trained personnel from the Omapomba village, and then the sign-off documents. And then we move on to our acceptance criteria. Our acceptance criteria, these are conditions that will satisfy our client. Upon completion of this project, our clients must be satisfied with this project. We have identified our acceptance criteria as the system must have 240 output voltage. We must have 1 light per room in every house with between 1,500 to 1,700 lumens per lighting. Then we must have an off-grid system. We must have a trained personnel to carry out system maintenance and operation. We must ensure that the system was properly earthed and the equipment clearly labeled, and we have to make sure that all structural equipments are properly mounted. Then I'll move on to our project constraints. We have identified one of the major constraints that have the possibility of contributing to our project to come to a standstill. We have identified the climate issues, the financial issue, operational issues as the major problems that might affect our project. Starting with the climate issues, the changes in the weather condition. We all know that solar energy is dependent on the sun. So any change in the weather condition may cause our system not to work properly. And then moving on to our financial issues. If we do not have adequate if we do not have adequate funds, this is going to cause our project to come to a standstill or to fail. Our operational issues. There might be issues of operation in terms of system breakdown, perhaps a component breaking down, or we might have load shedding, and and we'll make sure that we advise our end users, our customers, to cut down on the rate of energy consumption, because solar energy is only reliant on the sun. So when there's no sun that day, it's the rainy season, then they have to cut on their rate of energy consumption. All right, thank you, Mavis. I would like to hand the floor over to my next member to present to us the requirement analysis of this project. Thank you.
Thank you, Tim. My name is Ote Mafurila. I'll be presenting the second item of our project, subtitled Requirements Analysis. The requirements analysis we have are as follows. The first one is the input, and the second one outputs, the third one functions. Let me forward the slide a bit. The packaging, environment, and system structure, safety. So those are the 7 sub-items. I'll explain each of the sub-items according to the line of excuse me. I'll explain each of the sub-items. I'll start with the inputs. Our input is simply the renewable energy, or the sunlight, or the sun, the sunlight, or the sun that will be harnessed into, or harnessed by our solar panels. And output would be the electricity, being in 3-phase with a voltage ranging between 220 to 240 volts of 50 hertz. And the functions of the system is to harvest solar energy and convert it to direct current through photovoltaic cells in solar panels, Convert the kinetic DC output from the photovoltaic cells regulated by a charger controller that dynamically charges the batteries into potential energy. Convert direct current potential energy in batteries to three-phase 220 to 240 volts AC, 50 hertz of kinetic energy through an inverter that supplies the control panel that uses the electrical energy. Then comes the packaging. That's keeping different types of equipment in different kinds of storage depending on their design, characteristics, and accessibility. Example given, keeping or mounting solar panels on frame structures in an open solar yard. Environment. Observing environmental conditions conducive for protecting and enhancing the functions of different components of the system. Example given being dry and hot climate conducive for solar projects since the system depends on sunlight. Or air-conditioned battery and inverter storage to regulate temperature in hot and cold weather conditions. Sub-item number 1.6 is system structure, of which we have the use of the block diagram in our project to elaborate the system. Sub-item 1.7 is safety. The system should reliably provide electricity safely in a way that electric hazards are minimized from the point of production to the last consumer. This will be achieved by observing safety standards and operational procedures. I'll hand over to one of my colleagues to present us our next agenda item. Thank you.
Thank you very much. My name is Udirire Muruti from Botswana. I'll be presenting our agenda number 3 on analysis of alternative solutions. We chose solar as our source of energy. Firstly, we need to know what solar is. Solar energy is basically a method used to collect light and turn it directly into another useful form of energy. So we have 3 types of solar. The first one being solar thermal. In solar thermal, solar panels simply absorbs light, heats up and transfer the heat into working fluid. Normally, it is used for heating purposes, but the solar receiver can be used to produce steam. Then the steam is in turn converted to mechanical energy in a power conversion system, which then powers a generator to produce electricity. We move on to concentrated solar. Concentrated solar power. Here, electricity is generated by solar power using mirrors concentrated at a larger area of sunlight into a receiver. Electricity is generated when the concentrated light is converted to heat. The oil heats up to around 400 degrees Celsius, hot enough to heat water and make it high pressure steam that can drive a turbine or generate electricity. Our third type of solar is solar voltaic. In solar photovoltaic, electricity generated by conversion of light into electricity using the semiconducting materials that exhibit photovoltaic effect. The DC energy from the panels is passed through to the charger controller and the batteries. The DC energy is then inverted to AC for household consumption. We move on to our analysis of solar systems. Here we're basically looking at the benefits of solar, looking at the following factors being environmental, social, and economic. Firstly, let's look at the environmental. In environmental, solar uses sunlight as a renewable source of power. So it plays a pivotal role in reducing the greenhouse gases emission, and it helps in mitigating climate change effects. In turn, the ecosystem and its players, being the wildlife and humans' lives, are preserved. Solar also reduces water usage during energy production, considering the fact that water is scarce at our Amapumba village. Also, in turn, the quality of air is also promoted since no fossil fuels will be burned to produce energy. We move on to our social benefits of solar. Low to medium any households overhead cost for electricity will reduce. Reducing also the cost of living as electricity bills will go down. Skilled manpower will be required to do this job. As such, there will be job creation and the income to the people. And the income people will receive will improve their status quo. We move on to the economic factor of solar. On economic factor, electrification of Amapumba village will result in an increase in the market value of the village, as this is the betterment done should the people. As this is the betterment done should the people of that village decide to be involved in property management, the value of the property will be high due to its electrification. Move on to our next slide, where we will be discussing our force field analysis. A force field analysis is basically a grid analysis, which is normally considered before doing or engaging in any project. So we did our grid analysis basing on the four factors being the cost and durability, efficiency, and the climate. With 4 weights. So for the cost factor, we're looking at how costly it is to set up one source of energy to power our village. Either being concentrated photovoltaic or solar thermal. And the other thing we look at durability. How durable is our source of energy? Looking at how will it last. So we move on to efficiency. Here in efficiency, we are just looking at how efficient our source of energy can be as we move on. And the last one being climate. We are looking at the climate at our village, at Amapumba, because there we don't have, the water is very scarce, but looking at the sunlight, we are guaranteed 12 hours of sunlight. So on our grading system, on our grading of our first analysis, we give them all three because they will be located at the same location. So thereafter we do our weighting and we add those scores, and during our average scoring, photovoltaic scored based on our first field analysis. Photovoltaic scored 33 more than any other source of energy. So based on this, we choose photovoltaic as our source of energy to power our Puma village. So I'll be handing over to my next colleague to present our next item. Thank you.
All right, thank you, Oderilia. Our next presenter for our project risk is not here with us, so I would like to hand the floor over to Mr. Lawrence Mosidi to present to us the detailed system specifications of our project. Mr. Lawrence Mosidi, we cannot hear you. Our presenter for our project risk, Mr. Tamele, just joined us, so I'm sure he's still preparing himself. So I would like Mr. Mosidi to present for us a detailed system specification of our project.
Good afternoon, Mara. Yes, I'm loading the slide. I'll be just loading now.
Mr. Lawrence, I think we have a slide already on our board. So far, you can just and present your agenda item. It's part of the document that has already been, the slide that has already been uploaded. Thank you.
Okay, thank you. Good afternoon. Can you hear me? I'll just gonna start with that PV block diagram over there, which shows that from the sun, there is the PV array, whereby the sun rays are captured and converted into that energy, and then we do have the charge controllers Hello? Can I continue? Okay, from charge controllers, we are moving on to charge controllers. You split either to the DC load or it goes onto the batteries. And the batteries through a inverter can now give us an AC load if we are not using the direct current. And then the major components of our PV plant would then be the PV panels, the inverter, the storage device or batteries, the charge controller, and then the balancing system. With the PV panels, that's where most is the most critical part of the plant, which is made up of solar cells, and the solar cells then convert the solar energy into electrical energy. The panels, they convert that energy that they capture from the sun into electrical energy. And according to the capacity of the power plants, a number of plates are mounted, and the group of panels also known as the PV array. With the inverter, the solar panels, the output is in the form of direct current, and most of the load is connected to the power system network in this form. I mean, in the form of the alternating current. So for us to convert the DC into AC, we need that as such. That's the inverter. And for large, it's fortunate that here we're only to the Mpuba village, we're only electrifying the household. So I was just going to mention that if we had other major power consuming outlet like schools, like maybe shops, then there will be then in addition needed to have a transformer to the inverter so that you can boost the output. Okay, then the next of our components are the battery, the energy storage device, which in our case they are the batteries that store the energy generated from the solar panels. The component is used especially when the sunshine is not available, because when the sun is there, then it captures directly, but then the batteries are there just to store, so as to provide electric power when the sun is not there. And then the other component we have is the charge controller, which is used in charging and discharging of the battery. It also used to avoid the overcharging of the battery, because overcharging may lead to corrosion and reduce plate growth, which in that case may cause damage to the battery. And then the system balancing component, those are the control system, which protect and distribute power throughout the system, throughout the power plant. These devices ensure that all systems are working properly in good condition, and they optimize or make sure they utilize the energy in the proper direction. It also ensures maximum output and security for other components of the solar plant. So they provide protection. So this means if the system is not balanced, there's gonna be either the overcharging or the low current. And then we do have the blocking diode, which are connected to the battery. And these are then, during charging of the battery, the current flows from the panel to battery. When the sun is not available, the current can then flow in reverse direction, and this might cause damage to the panel, to the solar panels. So the blocking diode then is connected in between the battery and the panel to avoid this reverse current. So that's for protection. And lastly, we have the voltage regulator, which means that the output from the panels depend on sunlight, and the sunlight is not available all the time. We have some like now we are in a rainy season. It's cloudy, it's raining, so sunlight is not always there. So sometimes the output of the solar panel is also vary with respect to sunlight, and this is it results in fluctuation of the load. So the voltage regulators are used to maintain those fluctuations. Oh, yes.
All right, thank you, Mr. Lawrence Mosidi. I would like to move on to Mr. George Tamele to present to us the project risk of that he has prepared for this presentation.
Okay, thanks. I'm going to upload the shape file. Oh, oh, okay. Project risk. Okay.
All right. I can see Mr. Tamele came unprepared. Maybe we can hand the floor over to Mr. Rangarirai to present to us the work program structure while he is preparing to save time.
I'm prepared, but the slide is being changed. I don't know what's playing with the slides. So I thought maybe I would upload it and present it. Do you get my point?
Sorry, I have to interfere. Our group presentation is only dependent on this PowerPoint slide, so we cannot include other contents, other documents apart from this slide. So
Okay,
I think we
okay.
have to redo this presentation because there is no particular order. Are we fine with that? Because this is not in particular order.
Okay, so let them go for the right slide. I don't know where is it. I'm trying to find it. The project risk.
Mr. Tamele?
Yes, yes, I was just.
Time is not on our side. We have availed enough time for you. I would like Mr. Rangarile to just present his agenda point, and then you can get a chance because time is not in our hands. This is the group presentation. Okay, thank you. Having presented the key functions of our project, I would like to come to the conclusion of our presentation. The successful completion of this project will be made possible by proper work packaging as well as adequate funding. We have provided the network diagram as it was presented by Mr. Rangarirai to help the project manager to be on track and to be within the scope. Proper planning has also been done to ensure that there is no scope creep. By the end of this project, at least inhabitants of the Mapamba village will be able to say goodbye to primitive ways of lighting and be able to conserve their environment, which is a step towards sustainable development. Here is a big thank you from us, the Renewable Solutions Group.
Thanks. Bye.